This is the Cornerstone Bridge when simulated. Now we can see the nominal resistance 100 ohms at R2, R3 and R4. The variable resistance at R1, which is 139 ohms. When simulated as calculated, it will give us 0.816 volts. Now we'd have to amplify the 0.816 volts, in which we'll add a differential amplifier towards it. Remember that we have calculated the values for the resistance for the differential amplifier in the report, and you could check it to confirm. We have 123 ohms here and 1000 ohms here. Now this is what happens when the amplifier is connected to the bridge. Now, when connected to the bridge, you can see it is 0.096 volts, which is approximately 0.1 volt, which is what we want to achieve as the output voltage. Remember, from the brief given to us, we have the output voltage at 0 to 100 millivolts. So at full scale, we have 0.096, which is almost same thing as 0.1 volt.